There's nothing here about the golden ratio. There's nothing in any of these books. I've been looking for hours and I can't find anything. I quit. Detective solves multi-million-dollar murder case. I wish there was some sort of math detective. This is my multi-pan about math problems. You called? Who are you?
My name is Detective Al Gebra, and I'm here to solve your case of golden ratio confusion.
Well, Al, I have a 5-page paper to write on the golden ratio, and I don't even know what it is.
Have no fear, for Al Gebra is here.
Come on in. Have a seat. Alright. Well, let's get some background. First of all, you need to know that there's not really one inventor of the golden ratio. It's existed since the beginning of time, and the Greeks were the first to give it its name. They named it Phi, after the Greek sculptor Phidias. And then, later on in history, about the 13th and 14th century, there was a man named Luca Pacioli, and he was a mathematician, and he was the first man to actually thoroughly investigate the golden ratio and its use in the mathematical world. All right. And really what the golden ratio is it's a mathematical constant equal to about 0.618. And it determines what objects are visually pleasing. Okay, but I still don't understand. Well, let's see what I've got. Aha! Let's go on a historical journey.
Welcome to the Parthenon!
We're standing here in the middle of a golden ratio. The ancient Greeks used the golden ratio throughout all of their architecture. Really? Wow. Let's go see some more. Okay. Can't believe we're actually in the Parthenon. Wow, that was awesome.
Good. Did you learn a lot?
Sort of, but I'm still kind of confused about the mathematics part of the golden ratio.
Well, I can't really help you there, but I think I know someone who can. Hello,
Who are you?
I'm your fairy math mother.
Okay, good, because I need help.
Well, let's go to the drawing board.
All right.
First, you should know the exact value of the golden ratio, or also known as phi. It is 1 plus square root of 5 over 2. A simple equation to find the golden ratio in everyday life is A over B equal to B over A plus B. One can use the Parthenon as an example of the golden rectangle, another form of the golden ratio. Take A, the shorter side, or the height, over B, the longer side, or the base, and set it over each other. And it should, if it is equal to the golden ratio, it should be approximately 0.618. And then if you take B and then over A plus B, it should also equal about 0.618. If it does not equal this, it is not an example of a golden ratio.
Okay, that helped a lot.
Good.
I'm really getting this now.
Good. I thought you could.
Thanks, Fairy Math Mother.
Not a problem.
Good. I hate it. They should stop doing that. I wonder where else the golden ratio is found. Whoa, why is this tree here? This tree is here because nature is a big part of the golden ratio.
Really?
Yeah, nature is everywhere in the golden ratio. For example, in the sunflower. It's just everywhere. Wow, I thought the golden ratio was only used in the past and not in the present. Hello, the golden ratio is everywhere, and not only in nature, it's in your house too. Really? I didn't know that. Yeah, totally. Come on, I'll show you. Okay. So how do I find the golden ratio in my house?
Well, let's start with your window. We'll take the measurements and then do the math.
Okay.
The length is 68 1/4
All right.
by 42 inches.
Okay, so now what?
Well, now you got the calculations, we'll go to the whiteboard and do the math.
Okay. Let's see.
Let's start by drawing a diagram.
Okay.
the length of the small side?
42 inches.
And the long side?
68 1/4 inches.
Okay. Now, do you remember what your fairy math mother taught you?
About the golden ratio, the formula?
Yeah. Do you remember what it is?
I think it's A over B equals B over A plus B.
Very good. Okay, so the small side is always A, and the long side is always B. So can you tell me what the first fraction will be?
42 inches over 68 1/4 inches.
Now, if we plug that into our calculator, what do we get?
42 divided by 68.25 equals about 0.615.
If you remember, 5 is equal to about 0.618. So this is pretty close to 5.
That's really close.
Yeah. So that's saying that the rectangle of your window is really close to a golden rectangle. But just in case, let's check the other proportion.
Okay.
Do you know what that would be?
B, which is 68 1/4, over 42 plus 68 1/4, which is 110 1/4.
Very good. Now what's that equal to?
68.25 divided by 110.25 equals about 0.619.
That is also very close to 5 and very close to the previous one. So there's two ways to tell if it's going to be a golden rectangle. If the fractions are really close to each other or if they're really close to 5. So what is it safe to say about your window?
That it's a golden rectangle?
Very good. Now let's try one more and you can do the calculations.
Okay, let's go.
Okay, this time I'll just measure the picture frame and you write down the calculations.
Okay.
Okay, it's about 15 inches by 19 inches. So go ahead, do the calculations. So what conclusions can you make about your calculations?
Well, these two numbers aren't close to each other at all. And they're not very close to 5, which was 0.618. So I don't think it's a golden rectangle or a golden ratio.
Very good. I think that you should replace your picture with one that's more visually pleasing.
Me too.
So, do you understand the golden ratio better now?
Yeah, a lot. I think I'm ready for my project.
Good.
Better go get started.
The ratio is everywhere. It's all around. It's everywhere. I can't hide from it. Go.